Mark P. Otten back with you. Okay, this is a quick tutorial on how to run an SEM in R using the Lavon package based on a correlation matrix or a covariance matrix that is, let's say, from a published study, as opposed to running it straight from raw data. So this is cool to know because you might need it for your replication project in class. You also might, be just trying to impress somebody on a date. I don't know. Anyway, so seems unlikely. Anyway, okay, so you've got this relationship here. And first of all, the published study that you're working from probably has published a correlation matrix and not a covariance matrix. If it's published a covariance matrix, that's even better. But if it's a correlation matrix, you can still work with it if they've also published the standard deviations of the variables, because you can use this relationship here to convert each correlation to a covariance using those standard deviations. So if that's the case, then you can do that. Or if you find a study, you're lucky enough to find a study with a covariance matrix in there, then you can just take that straight over to R. So let me show you the website here. Okay, so this website is linked on your Canvas page, and it is what the covariance matrix is going to look like in your at the beginning of your R script. And so you enter in that covariance matrix directly into R, and then you can just run your model as usual below. So this website is showing you the steps. I figured, well, I'll just cheat off the website as opposed to typing in the code myself for this particular video. But this is why you need a covariance matrix, because R is not accepting a correlation matrix. So you can make those conversions if you need to, like I just mentioned, and then you type them in this format with lower arrow space apostrophe at the top, and then the covariance is laid out in a diagonal according to the order of the variables that you type in. So the corresponding order of variables comes in below here. This is the sample data set that the website uses. That's the name of the covariance matrix for them. You can name it something else for yourself in your work there. And then you've got GET capital COV. That's you're telling R, hey, go get the covariances. And then parentheses lower, names equals, that's all the fine print. C parentheses, and then you have the variable names quoted in there. So you can actually call the variables whatever you want. Of course, you'll probably want to match it up to what they're called in the published study if you're working on a replication. And so you put those variable names into quotes as opposed to apostrophes. And those then correspond to the columns in the covariance matrix that you just entered. And then, and so on. So the format there matches the order of the variables if you did it right. And you want to just pay attention to those commas and those parentheses and all the details there, the capitalizing the COV there. It's probably going to matter for R. And then you're good to go because you've got your covariance matrix entered. It's as if you have data entered now or imported. And then you can type in your model. The only other thing to mention and to emphasize here is when you get to your fit statement down here with your model, you want to specify, first of all, whatever you called it. So that's the name here from the example on the website. But then sample.cov equals, and then you want to match that name up to the name that you put up here for that covariance matrix. And then you want to enter in how many participants or subjects were in this study. So that's the other key. If they don't give you the sample size in the published study, then you're also stuck, but that's probably the most likely. They'll probably give you the sample size. That's it. So then you run this, you adapt the code to whatever model you're running and match up the variable names as well. And you have great luck because you run it without any error messages, and Dr. Otten is very proud of you.